In this example, I want to take a look at several relations and try to determine if they're going to be functions or not. Okay, so let's take a look at this relation here. So the relation is the association between -1, 3, 0, -1, 2, 3, 4, and 5. Now, a relation is a function if each member of the domain corresponds to exactly one member, or another way to think about it, only one member of the range. So does -1 only go to one number? Yes. Does 0 only go to one number? Yes. Does 2 only go to one number? Yes. Does 4 only go to one number? Yes. Now you may be thinking, whoa, -1 goes to 3 and 2 goes to 3. That's okay. It doesn't say that they can't go to the same number. It's just that -1 has to go to exactly one number or only one number. So this particular relation here is a function. Okay, let's consider this next relation. -1 goes to 5, 0 goes to 2, 3 goes to 4, and 3 also goes to -2. Now notice in this case how 3 goes to 4 and 3 goes to -2. So in this case, this relation is not a function because we have one input going to two different outputs. Now, if I were to graph this second example, so I've got -1, 5, I've got 0, 2, I've got 3, 4, and I've got 3, -2. Notice what makes this not a function is the fact that when the input is 3, there are two outputs, one here and one down there. So one way to think about this is to consider that if you can draw graphically a vertical line where that vertical line intersects the graph in multiple places, then that graph does not represent the graph of a function. And so in order for a graph to be a function, it has to pass what's called the vertical line test. Okay, let's consider the following graph. So in this case, we have a relation because we have x coordinates and y coordinates being assigned to each other. And so let's just consider this to be 3. So I have the x coordinate up here to be 3 comma something, and the y coordinate down, or the x coordinate down here to be 3 comma something also. Okay, let's call this y coordinate -2, and let's call this y coordinate +3. So this equation represents a relation because we have x coordinates or inputs being assigned to outputs. So looking at this, notice how 3, when 3 is the input, 3 is being assigned to 3 as an output, but 3 is also being assigned to -2 as an output. So this particular relation here, or this graphical representation of a relation, does not represent a function because we have, for one input, we have two outputs. And so if I think about drawing a vertical line, notice how that vertical line will intersect the graph in more than one place which means that the graph does not represent the graph of a function.